This is the second video in section 4.3, and we're going to do synthetic division. So hopefully you've done these before. It'll seem a little bit familiar, but it's kind of just a shortcut for the long division. So synthetic division only works if the divisor is in this format right here, right? So it has to be it has to be x minus c, whatever c is. So it could be x plus 3 because then c would be negative 3. It could be x minus 10 because c would be 10. Anything in that format you can do synthetic division on. The thing to watch out for is it has a first degree, right? It's only to the first degree. We can't do any x squareds or anything in synthetic division. And there's no number out here in front. It's all just a 1. Okay, if that's what we're dividing by, then we can do synthetic division. So basically it's the same, only we're going to kind of write it down like a shortcut because we're going to write it down without any variables. We're just going to use the coefficients, and that's the number in front of the variable. All right, now you can imagine this time I really have to write down zeros if there's not a variable there for a certain degree. Otherwise, how would I know the difference, right? So this doesn't have an x term. It's missing. The x term is missing. So I'll just put 0 there. So the first one is a 2. That was my x cubed. For x squared, I have negative 7. For x, I have a 0 because there's nothing there. And then for the constant, I have a 5. Now, I've seen different ways of writing the little box around it. This is the way I do it. Okay, now, I also, since I know it's always in that format, I can just put the 3 there, which is basically our c, right? Now, you notice that it's the opposite of what is there in the equation. I'm not just leaving off the x, but I'm using the opposite of what was there. Well, in just a second you'll see why that is, but it's handy because actually the opposite is actually our 0, right? But keep in mind that we've taken the opposite of that number right there. Now, since this is a 1, it's always going to be that the first number is just the first coefficient. So I bring this 2 just down. That's my first answer. Now, what did I do in long division when I got my first number up on the top? I multiplied, right? So now I'm going to multiply. I multiply this times 2, and I put my answer right up here. So I'm kind of going in diagonals. So 3 times 2 is 6. Okay? Okay, now, normally I would change the signs and add, but you know that I changed this sign, right? It's the opposite of what it was over here. So I've already changed the signs. I just have to add. Okay, so because I changed the sign first, I don't have to change the sign every time I'm going to subtract. I just have to add. So negative 7 and 6 is negative 1. Okay, now we're going to multiply. We always multiply the 3 by whatever number that is, and then we put the answer right up here, right? So 3 times negative 1 is negative 3, and then I add. So 0 plus negative 3 is negative 3. Okay? Now I multiply again. 3 times negative 3. I'm going to put the answer right here. So the answer is negative 9. Then I add, and I get negative 4. Now this last number over here, that's the remainder. And you notice that I started with x cubed, but I divided in a single degree x, so my answer will be in x squared. So I can write my answer from this as if I did it long division. It would have been 2x squared, 1 degree less than what I started with, minus 1 times x, minus 3, and then I could take my remainder and write it as a fraction with my original divisor, which is x minus 3. Okay, so this is what my whole answer would look like. But if I were just asking you for the remainder, this would be just the remainder. And when we do synthetic division, because we're always dividing by a first degree polynomial, our remainder is always going to be just a number. Okay, so let's talk about that remainder for a minute, because there is this theorem called the remainder theorem. And what it says is that if you do the synthetic division and you get a remainder, that is the same answer as if you just plugged in that number you were dividing. So if I took f of x, which would be my top, right, the thing before I divide, then, and I plugged in, so let's plug in 3. So this would be 2 times 3 cubed minus 7 times 3 squared plus 5. All right, so 3 cubed is 27, and 27 times 2 is 54. And 3 squared is 9, and 9 times 7 is 63 plus 5. So 54 minus 63 would be negative 9 plus 5 gives me negative 4. So you see what happened. My answer was negative 4. The remainder was negative 4. It's going to work like that every time. That's called the remainder theorem. And we do see it all the time when we look at zeros, right? If we got a 0 for the remainder, that would mean it would go unevenly, and that would mean that it is a factor, and that would mean that it is an x-intercept, which would mean when you plugged it in, you got 0. Okay, so that is where we're coming from, is from that remainder theorem. And we'll use this remainder theorem for a second. So here's a polynomial p of x. And suppose I wanted to find p of negative 2. Well, I could plug it in. But some of these numbers do get rather large. Right? So I could do it by synthetic division, by using the remainder theorem. Okay? So the remainder theorem says if I were to plug in negative 2, my answer would be the same answer as if I did synthetic division with negative 2 and I got the remainder. So I could do synthetic division and the remainder would be as if I plugged it in. Alright, so let's look at the synthetic division. We'd have 3 is x fifth, and 5 is x fourth, and negative 4 is x cubed, and there's no x squared, so that would be 0, and then 7, and then 3. And I'm going to divide with negative 2, which would be like dividing x plus 2, right? So the first one I bring down, and then I start multiplying and adding, right? So negative 2 times 3 is negative 6. I add them and get negative 1. Negative 2 times negative 1 is positive 2. And I should scoot that over a little bit. And I add them, I get negative 2. Negative 2 times negative 2 is positive 4, and I add them and I get 4. Negative 2 times 4 is negative 8, and I add them, I get negative 1. Negative 2 times negative 1 is positive 2, and I add them and I get 5. So this right here is my remainder. It also means that p of negative 2 equals 5. Not negative 5, just 5. Okay? That means go ahead and get a calculator out and check it. But plug in negative 2 into this whole polynomial. Take to the 5th degree. That would be negative 32. Times that by 3. And so on. Do the whole equation. You should get a 5. Alright. Here's a polynomial. And what I want to do here is I want to start finding the zeros. Right? So, for right now, I'm just going to tell you some to try. For example, negative 2. So, if I want to check and see if negative 2 is a 0, then I would do that by synthetic division, right? So, negative 1, negative 21, negative 11, negative 6. And if I wanted to check negative 2 as my 0, I'd be dividing by x plus 2. So negative 2 would go there. Alright, we're going to bring down the 3, and then we're going to multiply and add. So negative 6, that'd be negative 7. 14, that'd be negative 7. And positive 14, so that would be 3. Dang. Did I copy it down wrong? I copied it down wrong. Darn it. Okay, let's make that a positive 6. I copied it down wrong. Negative 6, that would be a 0. Sorry about that. Alright, so what that means is that x plus 2 is one of my factors. Okay, so if I were factoring here, I know that x plus 2 is one of them. Okay, now, we can do fractions. Not as fun, but we can do them. Bring down the 3. 1/2 times 3 would be 3 halves. If I had to get a common denominator to add, right, so the 7 would be 14 halves. Negative 14 and 3 would be negative 11 halves. 1/2 times negative 11 halves is negative 11 fourths. If I get a common denominator, that negative 7 would be 28 fourths. So that would be 39 fourths. Why do I think this isn't going to work? Times that by 39 times 8. Yeah, this isn't even a 0. Alright. There's no way that's not equal to 3. So, it's not a 0. Alright, I have about 10 seconds to give you the quiz question, because YouTube won't let me make this longer than 15 minutes, and then I'd have to start over. So here it is. I just want the remainder.